discussion on India's vibrant space sector. The participants are Professor Annapurni Subramaniam, Director, Indian Institute of Astrophysics, and Nigar Shaji, Project Director, Aditya L1 Mission. Moderator is Pallav Bagla, Senior Science Journalist.
Namaskar and welcome. India is celebrating its National Space Day, the maiden celebration or the first anniversary of that glorious soft landing near the south pole of the moon by India's Vikram lander, part of the Chandrayaan 3 mission. Prime Minister Narendra Modi declared that August 23rd here onwards would be the National Space Day. India has done very well in space technology. India makes its own rockets, makes its own satellites, and has some great science being done through both of these technologies. I have two very special guests to speak about India's space technology and science. I have with me Dr. Annapurni Subramanian, an astrophysicist, director of the Indian Institute of Astrophysics in Bangalore, and I have with me Dr. Nigar Shaji, till recently the project director for the maiden space-based observatory of India, Aditya L1, and now an associate director at the UR Rao Satellite Center in Bangalore, part of ISRO. India's space program has given glorious successes in the last 1 year. Let's start with you, Nigar. And first of all, congratulations both of you, Nigar Shaji for the Team Chandrayaan National Science Award, and to Dr. Annapurni Subramaniam for receiving the National Science Award, the maiden one. Both of you are really Nari Shakti for India, and you make us proud. Nigar, can you recall for us what have been the specific achievements of India in the last 1 year in space?
First of all, thank you for inviting me for this our first National Space Day celebration connected with that. So last year was really a fantastic and glorious year for ISRO. We have been in this space technologies for last almost 5 decades, but it all culminated in acquiring a lot more technologies of space, and it culminated in the landing on the moon, which only a few handful of countries have achieved it. And after the failure of Chandrayaan 2, we could again equip ourselves and to have that successful landing. And also along with that, immediately after August 23 landing of Chandrayaan, immediately on Aditya L1, we could have the first maiden solar observatory. For that launch happened in September 2nd. Subsequently, on January 1st, we had the first X-ray polarimetry XPOSat launch too. So it was successful and a glorious year as far as all the three are science missions. So it was a great successful year, and also it is a good initiative to have that landing of Chandrayaan 3 to be celebrated as a National Space Day, which give lot of awareness to our countrymen about the space work, what we are doing, and also the space technologies, which makes more and more participation of the public-private partnership along with the government institutions for more and more towards contributing towards the space economy too.
Continuing still with you, Dr. Nigar, you were there in the control room last August when Vikram lander safely and softly landed near the south pole of the moon at what is now called the Shiva Shakti point. What was your feeling when you saw the data that Vikram has landed like a feather?
Last few minutes since our lander started descending from 30 meter with the rough braking onwards, it was a little tense moment for us, and we were continuously monitoring the data and see every step of that landing after rough braking, and it went for soft braking and the final landing. It was really tense, and as soon as that when we saw that lander landing with perfectly on the moon surface, it was really a joy. All our tense moments have gone, and it was really a joyful occasion. It's a lifetime success what we have got over the past. Almost I have been in the space technology for last 30 years, but that is the culmination of that, whatever we have contributed to the organization. It was a very, very happy occasion. It was a memorable, lifetime memorable occasion.
I also watched it, and the whole country watched it literally. Those 20 minutes of terror and then the joy which we saw erupting in the control room and the Prime Minister joining in from his overseas trip, and the whole country really rejoiced. I'll come back to you, to Nigar, coming back to each of those specific missions you mentioned, and also talking a little bit about your bread and butter missions at ISRO. Dr. Annapurni, you are a scientist. What was your feeling when Vikram softly landed on the surface of the moon?
I want to wish all the listeners a very happy National Space Day, the very first National Space Day, and thank you for having me on your show. It is indeed a thrilling moment to have landed on the surface of the moon. It's a year ago, but it just feels like just happened a very short while ago. When you look at the moon, it always you felt that it was so far away, and then once you understand that we are able to land a rover on the moon, it suddenly felt as though it was so nearby. That is on just a feeling like a child. But the science, so complicated science, or so complicated technology, is able to reach out to people and make them feel so proud of our country and so proud of our abilities is completely overwhelming. And it's indeed a great decision to have that day celebrated as a National Space Day. And I'm really happy about it. And I look forward to more stunning things from the Indian Space Research Organizations in the future as well.
As a scientist, are you happy that India has done a series of interplanetary scientific exploration missions recently?
Yeah. So absolutely, because as a scientist, we always dream of bigger instruments, bigger ambitious instruments and missions to get more and more data, more and more observations, more and more measurements. And these are all required to get a holistic picture of how our solar system has formed, how the galaxy is evolving, and how we see the formation of planets in around other stars other than the sun. So in order to understand everything, we need to understand our own environment more. And nothing like going out there and exploring. And of course, space is a very harsh environment, extremely difficult to deploy things out there. And we've been consistently doing it right. And so that's really, really heartening. And I look forward to a lot more challenging missions in the future as well. As a scientist, really thrilling.
I can imagine the thrill and the good science which is emerging out of the missions is just now coming out. We will come to discuss the science output of these missions. Coming back to you, Nigar, can you recall one by one each of the scientific missions, starting with Chandrayaan 3, as to how difficult they were and how well they were executed? We go from Chandrayaan 3 to Aditya and then to Exposat, and can also we discuss a little bit about your bread and butter communications and Navik missions, starting with Chandrayaan 3.
Actually, bread and butter, because as you know, that ISRO was started with having a goal to improve the standard of living of common people, so that space application to help to do that. So we started with remote sensing and communication satellites, mainly for the application of water resource management, land cartography, so many applications on the remote sensing side. And similarly, on the communication side, we have been increasing our throughput and the bandwidth requirements of the people and the speed of the data transfer. So all those been done and having achieved self-sufficiency in such applications, and overall we could have our own all the space applications. We moved to space science, and as a full space science, because from the beginning we have some payloads being as a piggyback initially on the X-ray astronomy and things like that been happening. But as a whole science mission, it started with Chandrayaan 1, and then Chandrayaan 1, it's an orbiter, and followed by it, we have Chandrayaan 2, and then Chandrayaan 2, it was also a lander come orbiter, and followed by AstroSat, which is a multi-wavelength observatory solely for the astronomy. And then we came to Chandrayaan 3, and then followed by Aditya L1 and Exposat. And now we are planning a host of space science missions along with our bread and butter application missions. And over the years, we have mastered this technology because the landing technology is very difficult. As you know, we have to achieve it within the time frame. So many factors has to act as well within the limits. Then only the landing is possible. The landing legs, including the place where you have to load. So the camera has to work properly to identify the craterless surface. So lot of technologies, lot of sensors. So over the years, we have acquired all these knowledges, and we are now self-sufficient. Application-wise, we are further improving our resolutions so that it will help us in have a strategic applications too. And also on the communication side and space science, we have a lot of Chandrayaan follow-on missions. So finally, it will be culminated in landing on the moon. That's the present plan. And we also have a mission to Mars, and we have exoplanet observation. So the journey continues in the space science side as well as the application side.
Wonderful. Continuing with you, Nigar, tell me how difficult was Chandrayaan 3 to execute and how large was your team? And the whole team got the national award.
Yeah, because in space, for that matter, for anything, it's like complex missions which involves a multidisciplinary fields. It's always a teamwork. And if you take Chandrayaan, we have almost, because directly working is around 200 to 250 people, and indirectly much more people were working. So each that we had been working for Chandrayaan 3 before the launch for the last 2-3 years, at least 1 year we would have completely spent on the simulations. Because of the Chandrayaan 2 failure, we have completely on the simulation so that none of the conditions we will not leave no stone unturned, that you can tell, so that all the conditions we have innumerable Monte Carlo simulations and the other simulations so that we will not leave any condition untested. So the whole team was working tirelessly almost on 24/7 basis and to make it a successful one. So that was the result of what we got on August 23rd last year.
It was indeed a wonderful moment a little after 6 p.m. when the Vikram lander touched down at the Shiv Shakti point, and India created history by becoming the first nation to land closer to the South Pole and the fourth nation to land soft land on the moon. And let me emphasize for our listeners, when India succeeded a little before and a little after, 6 other missions failed to soft land. And these were for very well-to-do, very well-endowed spacefaring nations. America and Russia both had problems with soft landing. India did that gloriously. We'll come back to the other missions. Dr. Annapurni, the engineers delivered some of the engineering robots and payloads at different planetary bodies. Are the scientists happy with the whatever has been sent to different planetary bodies, and are the scientific results coming out looking good to you?
Yeah, I mean, I'm familiar with the AstroSat mission where we had basically a low Earth orbit mission where we had 5 instruments looking at the same part of the sky to do multi-wavelength measurements, right from visible to hard X-ray. They've worked a lot on the UV imaging telescope of that mission, as well as done a lot of science with it. I mean, it starts with the calibration and then performance verification and then continuous monitoring of the sensitivity of the detectors and performance of the entire system as such. So it's completing 9 years this September. So that mission actually was planned for 5 years and it has completed its life 9 years now. So it's producing fantastic results and creating a lot more interested astronomers, budding astronomers in the country. There are certain missions where there are engineering, the technical demonstrations more and the science relatively less compared to that. But still, they are producing a lot of science. And I'm happy to see that within the 1 year of landing, a Nature paper has been published from the science from Chandrayaan 3. So that has appeared in Nature earlier this week. So that is really, really heartening. And getting a publication in Nature, which has got high impactful result, is really amazing.
What is the key finding by that Chandrayaan 3 Pragyan rover paper which appeared in the highly regarded journal Nature? Maybe you can explain that and maybe I can also add something, Dr. Annapurni.
Just as the following, that the composition of the lunar regolith has been analyzed earlier. This is not the first time it's been analyzed, but from different regions, like the mid-latitude regions. And this is the first time it's been done from where the Chandrayaan-3 landed near the South Pole. So here the paper reports the measurements, the first in situ measurements of the elemental abundances in the lunar southern high latitude regions by the Alpha Particle Spectrometer APXS experiment on board Pragyan rover. And it has done measurements in 23 regions, and they find that the measurement is consistent throughout a large area in this region. And this particularly kind of uniformity of the few tens of meters proves an excellent ground truth for remote sensing observations, because previously when it was done, the understanding of the chemical composition on the surface is done by remote sensing. Like you take pictures and kind of analyze and say that this is the reflectivity and things like that, and this is the kind of material it should be reflecting like this. But now you have actually gone there and then taken in situ measurements, like you have put the probe in and then made the experiment there, and that really confirms what it is out there. And this got huge implications on the how the moon is formed and why the current composition of the surface is the way it is. So it's a really impactful study.
Certainly. I can add something on what Dr. Annapurni has said. This particular paper is the first big paper which has come out of Chandrayaan-3, and it really shows that once the moon, which we see as a cool, white, luminous body today, 4 billion years ago, it was a fiery, molten rock mass. And the hypothesis that it was a molten magma on the moon, that gets confirmed by this particular finding. And it is a high impact paper. And anything which India did at Shiv Shakti Point in situ analysis was to be a novel finding, because no other country had gone there. Dr. Annapurni, you also had some instruments on Aditya L1, which is India's maiden space-based solar observatory. Can you tell us how your instruments are doing and what are some of, if any, scientific findings?
The Aditya L1 mission, one of the main instruments on that is the coronagraph. And coronagraph would mean that the instrument will see the sun as though it is going through a total solar eclipse. So this is a highly complex instrument where you have to collect all the light coming from the sun, but selectively block the light of the central disk, which is the most brightest part of the sun, and only collect the data which is surrounding the disk. And that's a very complex way of doing it. And that what you get of that particular instrument is an image of the corona, and also the spectroscopy, in the sense you find a particular line and then find the intensity of that line and measure the Doppler shift, so how the matter is moving in the corona. So right now we are going to almost completing the performance verification stage, the last stages of it, where all the complex instrument and various modes of operations are being completed. And we've been looking at certain areas where the solar flares are happening and comparing the flare strength with the ground-based observations which we get on the flare strength as such. So we are able to correlate with the kind of the intensity which we see in these lines versus the flare which happens after that. So you are seeing the kind of intensity on the sun, and then after a few days the plasma is hitting the earth with a kind of a burst. So we are able to correlate that. So that study has been going on the last 1 month or so, but we look forward to getting more results once the verification is completed.
For a layperson, once in a while the sun gets very angry. So will Aditya L1 be able to tell Indians that the sun is going to get angry and Nigar Shahji needs to protect her satellites from its fiery flares? Dr. Annapurni?
When we look at the corona, we will see the ejections from the sun, that is called the coronal mass ejections, and the large amount of plasma leaves the sun. And then we will be able to measure the velocity of these ejections. And we can also combine that information from the ground. We observe from the Gauri Bidhanugar Observatory the plasma which is leaving the sun, actually predict how long it will take to reach the surface of the earth or near the earth, so that we can protect the spacecraft around it. That's the idea, but we are still demonstrating that.
Fair enough. You have a busy time with so many different scientific satellites in orbit. Nigar, tell me a little bit about the future bread and butter missions by ISRO, which is the communication satellite, the Earth observation satellites, and the navigation satellites. How is it progressing? We have over 50 in our constellation already.
Coming to remote sensing satellites, actually now, as you are aware, since the space reforms, we are making satellites on the basis of demand-driven ones. So we have to get the requirements or the demands from the different ministries or the private sector or from the security agencies, and then we'll be doing the necessary remote sensing spacecrafts for that. So presently we have been improving the resolutions of our Cartosat 3, which is of the order of 25 centimeter. So that same cartography spacecrafts, which are in lined up, almost 6 numbers we have to. And also we have water and the land resource management spacecrafts, which is a ResourceSat series. And in that we are planning 2 spacecraft facing so that the temporal resolution can be improved. So it is on the remote and also on our ocean studies side, we have the forthcoming, already our OceanSat 3 is in place, and it will be further augmented with OceanSat 3A so that we will have a better temporal resolution. So that's the thing which is going on. Apart from that, our science missions are also getting shape, like Mars landers, Venus orbiter mission, and further ExoWorld and the further moon landing missions for to culminate in the landing on the moon. So this is on the remote sensing and the planetary side. On the communication side, we are continuously improving on to have we are planning to have a software defined radio. That is, what is it called is our bandwidth and the antenna pointing and the coverage, everything is a programmable one. So that is one aspect of it. And also the big throughput satellites, like a bigger number of transponders and the way extending the coverage. So communication side. On the navigation side, we are into the new series, an NVS series of navigation spacecraft, where we are trying to include more bands, because presently we have L1 and S band and L5. L2 also is getting to be included, and we have a MEO constellation also supporting this navigation, so that extending the coverage is the aim of that. And so that new series of IRNSS, that is NAVIC spacecrafts, that is one series is being planned. These are on the application side. These are all the 3 areas and the space science that we have been working on.
Towards the end, coming back to you once again, to Nigar, can you tell me a little bit about what is the progress of Gaganyaan? Gaganyaan is India's most ambitious scientific experiment to send an Indian Gaganyatri to space on an Indian rocket from Indian soil, and the country is spending 10,000 crores on that. How is the progress, and when will we see our Gaganyatri in space from Sriharikota?
For Gaganyaan, we have to have 3 successful missions before we fly astronauts into the space in that mission. So we are working on the first G1, G2, G3, and then the H1, that is the human mission will start. So we are planning to have by next year, March, the G1 mission, so that followed by G2 and G3, then our astronauts in a time frame of maybe 2 years, astronauts can fly in the Gaganyaan missions. And followed by that, we are also working on the Bharatiya Antariksh Station. That also of 2028 time frame, the first module of BAS is also planned to be launched. This is the progress on the Gaganyaan side.
Will we be able to send an Indian Gaganyatri and bring it back safely?
Yes, that's why we are having these continuous successful missions that ensures that astronaut can be sent and brought them back safely and securely.
Well, we currently have an Indian origin astronaut, Sunita Williams, who some say is stuck at the International Space Station. That's a separate discussion. Let's not go there. I'm hoping Gaganyaan will do much better and take an Indian and bring them back soon. Dr. Annapurni, does human space flight excite scientists, and can any experiments be done using human space flight?
Yeah, I think there are a lot of things which can be done in space, like the International Space Station, the biology, and how chemical and metals react, etc. I'm not very sure about those reactions, but then there are a lot of experiments which are conducted in the International Space Station. And I think a lot of things are being planned also. That's what I understand. A wide variety of science experiments can be carried out there.
Do astronomers want a space-based observatory which humans can operate in human orbit? Would that be a good experiment for a scientist like you to try and get it undertaken through ISRO?
Absolutely, because you can actually, the one of the important things is that if you have an observatory close to or on the International Space Station, then you can actually go and change some instruments or, modify certain instruments. This opens up a very different ball game because till now, if we launch a satellite or an instrument, you just leave it there until it completes its life and its a scientific purpose. But here you can actually modify it, and then just like you can we've been doing it in the Hubble Space Telescope mission. So like that, you can actually modify and things like that. So that opens up a completely different window, and that's quite ambitious. And maybe sometime in the future we can do that.
Nigar, towards the end, are you excited about the space reforms and the future of scientific and technological missions which India is undertaking?
Yes, definitely. Space reforms is going to bring in a lot of public-private partnership to us so that our contribution towards the space economy grows and the employment grows so that national economy also grows in the space sector. And see, we have very, very exciting missions up to 2035, 40. We wanted to land on the moon. That was the present plan. So we are the total exciting years ahead for us ISROians.
Thanks a lot. What I can tell you is whatever India has invested in the Indian space program, there's a new report which says for every rupee invested, the return has been of the order of 2.5, which means for every rupee invested, the gain has been 2.5 rupees. It's an amazing rate of return, and it shows that the investments in India's space program have been well justified, and the National Space Day is celebrating all of that success. Thanks a lot for joining me, Dr. Annapurni Subramanian, Director of the Indian Institute of Astrophysics in Bangalore, and Nigar Shahji, the lady who took us closer to the sun with Aditya L1. Both of you are role models for India, and both of you symbolize Nari Shakti, India's space program.
Thank you.
Thank you.
You were listening to a discussion on India's vibrant space sector. The participants were Professor Annapurni Subramaniam, Director, Indian Institute of Astrophysics, and Nigar Shahji, Project Director, Aditya L1 Mission. Moderator was Pallav Bagla, Senior Science Journalist. This program was produced and presented by the News Services Division of Akashvani. You can listen to it on our mobile app, News on AIR. This program is also available on our YouTube channel, News on AIR Official. You may share your feedback about this program through email at airnsdtalks@gmail.com or WhatsApp on 9289094044.